Hey, this is Brock Lemires, and we're continuing our study of embedded systems design. We have switched over to the programming language C, and we're looking at timer overflows on the MSP430 Launchpad board. In this video, we're going to look at specifically generating a timer overflow using SMCLK as the source, but seeing how we can actually slow that down by using a divide-by-4 prescaler. So recall that an overflow is where we put the timer into a situation where we let it go from its lowest value to its highest value. So in this case, a 16-bit timer will go from 0000 up to FFFF. And we're going to leave it in 16-bit mode, and we're going to let it go all the way up, overflow, raise a flag, and then start counting again. We will put that in continuous mode to enable it, and then we'll track a flag every time it overflows. And we've looked at using a really slow clock, a clock, which was 32 kilohertz. And then we looked at how we could speed that up by changing the timer length to 12 bits. So instead of going to FFFF, it went to FFF. And then we looked at switching to even faster, which was SMCLK. And now we're going at 1 megahertz. But then we're like, well, could I slow that down? Right? So we've looked at a slow clock that we sped up. Now we looked at a fast clock that we're going to slow down. So we're going to use the first stage divider, and you'll see these called PreScalars a lot of time because you scale down the clock pre-timer. And so you can call it clock divider, but you'll see it at PreScalar. You'll see that term used a lot in the data sheets. But I want to set this to a divide by 4. And I'm going to do that by setting the ID bits to 10, which happen to be in the TB0 control register. So lucky for us, it's all the same control register. And what that's going to do is it's going to give us a clock that drives the timer of actually 250 kilohertz. So it's 1/4 of the 1 megahertz. Okay, so how does that change the overflow period? Well, the amount of time on a timer is always calculated by the period of the clock times the number of counts. So in this situation, our period of our clock is going to be 1/250 kilohertz, or said another way, 1 megahertz divided by 4. We still multiply it by 2 to the 16 because that's how many counts are going to happen before it overflows. And that turns out to be an overflow period of 262 milliseconds. So roughly over 1/4 of a second. When that happens, I want a flag will be raised, and I want to use an interrupt to trigger an interrupt and execute an interrupt service routine. So we are going to use the TB0 IFG flag, which is associated with the vector table address timer 0B1 vector. So that's where you're going to get where we're going to put our interrupt service routine address. And what do you want to do? Well, let's flash the LED again. Okay, why not? Why change? So we're going to have an interrupt service routine that's going to toggle the LED 1 on the Launchpad board, and it'll go awesome. All right, let's fire it up. So let's get a new project, file new CCS project. As always, let's give it the prefix C, and then we'll do timer, timers, and then we'll call it SMCLK, and then we'll do overflow, something like overflow, and then we'll do div4 to show that we're doing something a little different. Choose our main.c and grab the wrong window, and boom. Okay, so let's take a look at this. Here's our skeleton that CCS has provided for us. And let's go down here, and first and foremost, we're going to use LED 1. That means we need to set up the ports. So let's change the set port 1 bit 0 to output, and this is LED 1 on the Launchpad board. Port 1 bit 0 can be configured, its direction can be configured in the P1 DIR register, and I'm going to perform a bitwise OR with a mask called bit 0. And that is going to, what that's going to do is it's going to go set bit position 0 in this register. Now, where did these names come from? The bit mask name was a define in the header file, and as was the port 1 DIR register name. So these are all provided for us in the header file. Okay, so that's nice, makes it readable. Now I want to, let's do this. Let's go set port 1 bit 0 low initially, and that's LED 1, of course. All right, and then I do that by writing to the P1 out register, and I'm going to clear it. So when I clear a bit, I'm going to go ampersand equal tilde. And I use that same mask, but since I did the little tilde on there, it inverted the mask and it got it in a form that I can use a bitwise AND operation to basically clear out bit 0, leave everybody else in the word the same, or in the register. Now the last thing we want to do is turn on digital I/O, and we can do that by clearing the lock LPM 5-bit in the power module 5 control 0 register. Again, I'm going to clear, so I'm going to go ampersand equal tilde, and I use a bit mask from the header file called lock LPM 5, and that's it. Okay, so our LED is now ready to be used. And now let's do this. We got to set up the timer. And we are setting up timer TB0 because that's what we've been kind of looking at. I could use timer B1 if you want to. But hey, man, if it ain't broken, don't fix it, right? So now everything that we configure is in a TB0 CTL register. This is a control register. So all the bits are in here. Well, yeah, everything's in here that we're using. I need to first and foremost write a 1 to the TB clear bit to reset the timer. Okay, so that's the recommended programming procedure by the datasheet. And so I'm going to do a bitwise OR to set the bit TB clear. That mask was provided by the header file. So I'm going to reset the timer. And now what are we going to do? Let's put it in continuous mode. So let's do the timer. We can use length as the same. We'll use the default 16. Let's do the mode control. So let's do this. I'm going to go TB0 CTL, and I need to do a bitwise OR to set the bit called MC underscore continuous. Okay. Now that bit is choose continuous mode. Kind of funny, you know, when the bitmasks are really readable, the comment seems redundant. But anyway, all right, so now let's do this. Now let's go choose our clock setting. So this time we're going to do something. We're going to go into these bits TB SSEL, and we're going to choose SM clock. And I do this. It's also in the TB0 CTL register, and I do a bit set on a mask called TB SSEL __ SM clock. And that's nice, okay, because it's readable. So now I'm going to do choose SM clock. SM clock, and that's 1 megahertz. And now here's our new setting. So now we're going to slow that buddy down by going into the ID bits and configure them as 1, 0. And if you can believe it, okay, there's actually a bit mask called ID __ 4. And where am I finding all these? I mean, you're like, where are you pulling these names out of? I'm telling you, they're in this header file. So you got to go look in the header file. And remember, when you expand the header file, it's going to have like a billion, no, not a billion, but probably a big number, thousands of header files associated with our specific device. And so you got to go look in the specific one. Ours is the MSP430 FR2355. And now we're going to divide by 4 to get 250 kilohertz as our timer clock. Okay, that timer is set up. We're ready to do interrupts. So let's set up our IRQs. And so we need to, let's enable the local enable for an overflow in timer B0. So in the timer B0 control register, we're once again going to do a bit set on a mask called TBIE. So this bit is the local enable for TB0 overflow. And now let's do the global enable. So I'm going to use this function called enable _ interrupt, and I want to turn purple. Yes. All right, and now we're going to do this, enable maskables, and that's going to enable all the maskable interrupts, but only the ones that have their local enable enabled will be able to trigger an interrupt. They can raise their flags, but they don't trigger interrupts. Okay. All right. So now the last thing is I'm going to always clear this this pesky flag. I'm so paranoid that it's going to be in the wrong value. So let's go ahead and clear. So I'm going to go ampersand equal tilde, and the flag is called TBIFG. Okay. So that's going to clear my mask. Not mask, flag. All right. We are set up. We're feeling pretty good. So it's time to do what? Nothing. I'm going to do a main loop, which will do absolutely nothing but spin. Okay, so let's just do a while 1 and open, close, done. So I'm gonna loop forever. And we're gonna sit in this loop until an interrupt fires. So it'll overflow, flag raises, trigger an interrupt, and now we need to go write the interrupt service routine. So we're now leaving the main loop, okay, the main function, and I'm ready to start my interrupt service routines. So I need to do, here's my ISRs, and first and foremost, the routine starting address that we're gonna enter right now needs to be put into the vector table for timer B0 overflow. So I need to tell the compiler using Pragma that I am trying to set the vector address for this name, timer 0 underscore B1 underscore vector. Wow, what a name, huh? It ain't Timber either. Timer 0 B1, where in the world did that come from? Well, it came from this thing. This table in the compiler, compiler data sheet. Actually, I don't even know. I think I found this in the linker file and I made this table for you. You're welcome. So timer. Anyway, that's the syntax, okay? All right. And now it's time to write a routine, except you do not return from this routine using your return from subroutine. You return using return from interrupt. So we got to put this little function there to say this is a special routine. And now we just write a routine kind of in standard C syntax where we go void, overflow, and we're not passing in any arguments. And now we're ready to open, close, and now we're here. What are we going to do in our interrupt service routine? Let's toggle LED1 using a bitwise exclusive OR with the mask bit 0. So this will toggle LED1, and now are we done? No way. We got to clear that flag. Otherwise, it will immediately fire again, and we'll come back here and we'll get in this infinite loop. All right, let's go ahead and let's do some compiles and see what kind of typos we just created for us. Okay, what do we got? So I got cancel. You probably saw it as I went by. Line 21. Okay, expecting a semicolon. Yeah, that's a colon right there, folks. There ain't no semicolon. All right, so go ahead and hit that again. Got another error. Probably another one of them, huh? So expected that on line 35. Hey, look at that colon popping up. I haven't seen that one for a while. For some reason, I decided to start typing colons. Is there a third mistake? Doesn't look like it. All right. So download. All right, so it's time. Let's get ready. Let's take a look at the board. So here's the board. Here's LED1. And now let's think about how fast it's going to flash. So every 262 milliseconds it's going to turn on or off. Okay, so it's going to turn on, off, toggle. 260, a second is 1,000 milliseconds. So this is about 25%. It's 26.2% of a second. But basically it's going to go on, off in about a half second, and then on, off in another half second. So every second it's going to go on, off, on, off. So it'll flash twice every second. Not exactly. Okay, we can't get exact using an overflow, but about. So let's go ahead and see, number one, did our program even come close to working? And then two, does it toggle at about what we think with this divided down clock? Okay, so number one, let's just go for it. Boom. Yes, look at this thing. So it's toggling. Something's happening. Life is good. And how fast is it going? It's like 1,002, 1,001, 1,002, 1,001, 1,002, 1,001, 1,002, 1,001, 1,002, 1,001. Awesome. Because, yeah, it's doing it. It's about every second you see the thing flash about twice. So we did it. We did it. Check out what you just did. You set up a timer overflow that triggered an interrupt, and that interrupt service routine toggled LED1. But more importantly, you chose SMCLK, which is 1 megahertz, as the source, and then you divided it by 4 to slow that thing down to set the overflow period to 262 milliseconds. Wow, nice job. All right, that is it. As always, support my channel by subscribing and see.